Why do people say that the more advanced technology becomes, the more despair humanity feels? As the highest form of intelligent life in the vast universe, we still cannot even leave the solar system. Some scientists even believe that humans may never be able to leave the Milky Way. Even if one day we could travel at the speed of light, it would still take at least 24,000 years just to reach the edge of the galaxy. And compared to our slow pace in the universe, higher civilizations may possess a form of transportation capable of instantaneous travel. No matter the distance, they can arrive in a single moment. This is the wormhole. What exactly is a wormhole? Why is it considered the dividing line between different levels of civilization? And can it really allow travel through space and time? Watch this video carefully. It will completely overturn your understanding of wormholes. Wormholes are also known as Einstein-Rosen bridges. In 1935, Albert Einstein and Nathan Rosen used general relativity to explain this concept, proposing the idea of a bridge connecting two different points in spacetime. Theoretically, such a bridge could shorten travel distance and time by creating a cosmic shortcut. This is the Einstein-Rosen bridge, the wormhole. From a mathematical standpoint, Einstein's theory predicts the existence of wormholes. However, humanity has yet to find any evidence of one. Even though certain equations suggest that black holes could act as wormhole entrances, we still cannot prove whether black holes are wormholes. After all, anything, matter or human, entering a black hole would disappear forever. This brings us back to the concept of space-time. Einstein's theory states that space and time combine to form a structure, and that structure forms the foundation of the entire universe. Earth, the Sun, and galaxies behave as they do not because of gravity itself, but because they warp the space-time around them, creating valleys that trap other celestial bodies and make them orbit. Thus, Einstein proposed that space-time can be stretched, twisted, compressed, and even torn apart. Wormholes were originally theorized from this idea. If a hole in space-time can be opened, then something must exist on the other side. Einstein and others suggested that there could be 5 types of wormholes in the universe. Below is a basic explanation. 1. Traversable wormholes. The most well-known type, often seen in science fiction films. They allow objects to pass through and emerge at a different location in the universe, similar to the wormhole in Star Trek Deep Space Nine. 2. Non-traversable wormholes. Nothing can pass through these. They either collapse instantly or destroy anything that approaches the exit. 3. One-way wormholes. You can go through in one direction, but returning requires another wormhole. Some Einstein field equations suggest such wormholes may exist inside black holes, though they are not traversable. 4. White holes. These play a special role. Opposite of black holes, they eject matter outward instead of sucking it in. 5. Two-way wormholes. These allow travel in both directions. By scale, wormholes can be divided into intra-universal wormholes, connecting two distant parts of our own universe. Inter-universal wormholes, connecting our universe to a parallel universe, as often depicted in DC or Marvel comics. Wormholes come in many forms, each with potential impacts on the universe and the life within it. This leads to an important question. Where are the wormholes in our universe? As mentioned earlier, many wormholes have been proposed only as theoretical possibilities. They may relate to black holes, white holes, or massive galaxies, yet none have been proven. This does not mean wormholes do not exist, only that they are in a state of possibly real, possibly not, similar to dark matter and dark energy. Mathematics and physics strongly support the possibility of wormholes, but possible does not mean guaranteed, much like countless things in life that are theoretically possible but never happen. Even though relativity is a profound and highly successful theory, it is still a theory.
If you dive deeper into the mathematics, you will find multiple possible interpretations and outcomes, meaning wormholes are only one of many possible realities. This may explain why wormholes exist only in our imagination for now. But what if the conditions needed to create wormholes simply do not exist yet? Then perhaps we haven't found wormholes because none have formed, or because we ourselves must create one. Science fiction often depicts ships tearing open space-time and forming their own wormholes. So maybe wormholes are out there, or maybe we just haven't discovered them yet. But how could we miss them, you might ask? Remember, the universe is unimaginably vast, spanning trillions of light years, and we can observe only a tiny part of it. We can detect stars and planets in distant galaxies, yet we are still discovering new moons around Jupiter and Saturn, right in our cosmic backyard. Why can we see things far away but miss things nearby? Because no one can observe the whole universe at once. Even if Earth were a giant telescope, we still couldn't watch all celestial bodies simultaneously. Thus, many things slip through unnoticed. If wormholes exist, when were they created? The most likely answer, the Big Bang. Scientists believe the universe was born from this event. The explosion created vast quantities of matter, causing the universe to expand and form its structure over billions of years. This violent process may have also created countless voids and tunnels, potential wormholes, waiting to be found. But consider this: if the universe had only 5 wormholes, each with an entrance and exit, randomly distributed across the universe, what are the chances one lies near us? And even if it did, could we recognize it? Would we spot it in the darkness of space? In Star Trek, a wormhole only becomes visible when a ship approaches it, and even then, stable wormholes are extremely rare. All of this suggests that perhaps we cannot find wormholes simply because we do not know where or how to look. There is also a theory that the centers of galaxies are wormholes, not black holes. If true, all galaxies may be interconnected through cosmic tunnels, forming a far more unified universe than previously believed. But even if wormholes exist, can they remain open? Space-time holes are considered open structures, but there is a force in the universe that actively closes things: gravity. If a wormhole existed, would the universe allow it to remain stable? Probably not. Deep space gravity would try to pull it closed. Black holes survive because their gravity is overwhelmingly strong, but many black holes eventually evaporate through Hawking radiation. Humans can create microscopic black holes on Earth, but they last only seconds before disappearing. Thus, if wormholes exist, they may collapse quickly unless supported by an unknown energy source, perhaps what theories call cosmic strings or exotic matter. If wormholes formed during the Big Bang, billions of years of gravitational forces may have already closed them before we began searching. Still, the idea remains exciting. If wormholes exist, what would it mean? And if humans could create a wormhole, a stable, traversable one, what would we do with it? If they exist, they provide a cosmic highway, allowing us to reach the far side of the universe without long journeys. Even warp drives, like those in Star Trek, have speed limits. But a stable wormhole would be priceless, letting us explore unreachable galaxies and uncover their secrets. If humanity could create wormholes, true interstellar travel would finally begin. Imagine traveling through space, creating a wormhole, escaping Earth's gravity, and reaching Mars in seconds instead of months. Colonizing Mars would become
Vastly easier. Reaching Titan or even Alpha Centauri would no longer be impossible. Wormholes would be the ultimate secret of space travel. Instead of building faster ships, we would only need ships strong enough to survive the turbulence inside a wormhole. It is a beautiful dream, but at present, it is only a dream. One that excites countless sci-fi fans and scientists alike. Theoretically, yes, one day humans might travel through wormholes. But whether we truly can, only time will tell. After all, time itself is part of space-time.